Hi there, welcome to my hobby room. My name is Tony Porzio and I'm a project engineer with the Aerospace Corporation. For over 60 years, aerospace has been a federally funded research and development corporation that has helped a lot of people put many things into space to do a lot of different jobs. Our company has many people who are experts in building spacecraft, and some of those are here in Albuquerque. Currently, aerospace is involved with building CubeSats or microsatellites. These satellites are only a few inches across, like this model here, but they can still do a great number of tasks. CubeSats can take pictures of the Earth from space, provide communication channels for other spacecraft, monitor space weather conditions, and many other tasks. When we come to the museum for Discover STEAM Day, we like to show everyone our models of these satellites and how they're deployed into space. We also like to demonstrate some of the engineering and technology involved in building them. One of the things that makes these satellites very versatile is the electronics inside them. Most of these small satellites are built around a device called a single board computer. An SBC is just like any other computer you would use, except everything it does is on a single piece of circuit board. And these computers are getting more complex all the time, just like all the other computers and devices we use. But how can you learn about science, technology, engineering, the arts, and math from a microsatellite single board computer? Well, there's a type of single board computer that's very easy to use, and people like me use them all the time for hobby projects and also to teach students about technology and engineering. These SBCs are called microcontrollers, and there are a lot of them right in your house. The disc player, the microwave, the washing machine, any device where you're just pushing a few buttons to get things done is probably using a microcontroller. The most common microcontroller that people like me use for hobby projects are called Arduinos. And this is the simplest one of the Arduinos. This is called an UNO. Arduino is the name of the company that designed them, and UNO is their simplest single board computer. I've used UNOs to build controllers for various parts of my model railroad, and I've also used them to build a simple robot to demonstrate just how easy it is for anyone to have a robot laboratory in their home or school. Let's take a look at the different parts of the UNO. First of all, on the left here we have a USB port to attach the UNO to a computer for programming. Then under that there is a port to power the UNO when it's running. Toward the bottom edge is the processor chip, and along the top and bottom we have things that are called headers. Headers are where you make all the connections to do the things you want the UNO to do for you. You can program the different connections either to take in data or to control different items. And the best thing about microcontrollers like the UNO is that there are many different devices that can generate data that the UNO can understand. This is an assortment of sensors that can be used with the UNO. There are sensors for detecting temperature and humidity, sensors for finding an open flame, sensors for detecting objects and measuring the distance to them, sensors for sound, and many other things you can use for various hobby and robotics projects. And what can the UNO control? Well, just about anything that uses electricity. The UNO by itself can run things like LED lights, or with just the addition of a few electronic components, the UNO can run various types of motors. So at this point you might be saying, okay Tony, that's an UNO and that's nice, but really what can it do? Well, the best way to describe this is that the UNO can give your hobby projects or your toys a brain. And you can use it, of course, to build simple robots. Even if you're not ready to start building a microsatellite, you certainly can start building a simple robot with an UNO or simple hobby projects. But I think the best thing to do is to actually show you an UNO at work. And to do that, we're going to take a little trip back, about 65 years. When your grandparents were young, they had toys like model trains and erector sets to teach them about engineering and technology. Those toys were great fun, and it really helped them learn about how to build things. And this is one of the things they might have played with. This is a burning switch tower. It was an accessory for a toy train layout, and it was meant to simulate a railroad building that's on fire. The building has an interior light, a set of blinking fire lights, a smoke generator, a strobe light to simulate an electrical short circuit, and a mechanism to make the crew figures move. Now, when your grandparents played with this, they had to push a bunch of different buttons to make it do all the things I just showed you. Fortunately, we now have our UNO, and we can program it to do all those functions by itself. This is a controller for the burning switch tower based on the UNO. This is just like the UNO I showed you before, but it also has some extra parts that I've put together to make the different parts of the burning switch tower operate. So let's go ahead and turn it on and see what happens after I push the start button. The first thing we see is a bunch of sparks and flashes of light in the first floor as something's starting to go wrong. It looks like there's an electrical fire starting. As the sequence continues, the light in the switch tower turns off, and then the men start running in and out of the building as the flames burn. Then finally there's smoke coming out of the doors and windows. This will keep going on for about a minute until the sequence is done, and the UNO will reset back to where just the inside light is on, and it's the UNO that did all those things based on the program I wrote for it. Are you interested in learning more about how to use microcontrollers like the UNO? If you want to learn more about it, and maybe about how to program it and about electronics that you can use to interface an UNO with different projects, then your next step is to take a look at the handouts on our Discover STEAM Day virtual booth. We have two handouts at our booth that are good lists of resources to help you learn about how to program a microcontroller like the UNO and about electronics to interface a microcontroller with various hobby projects. You'll also find sources for purchasing controllers like the UNO as well as various electronics devices. And the best thing about all these is that they're not expensive at all. And we're going to have a raffle for an UNO kit for anyone in grades 6 through 12. If you're a parent or guardian with a student in junior high or high school, leave your name and email address at our virtual booth, and we'll pick a winner at random for this Arduino kit. And for those of you who are teachers and educators, the Aerospace Corporation has many ways to help you teach space technology and engineering to your students. We have many volunteers like myself who are ready to come to your class to talk about space technology as well as space careers. We also have resources from our corporate offices for STEM-type projects for your classroom. We're also ready to assist you in developing STEM curriculums. So even though we just have a few minutes together today, there will still be opportunities for the Aerospace Corporation to help you bring space to your students. If you're interested, the contact information is on the screen. Thank you for your time today, and I hope you've had some fun learning about microcontrollers and what they can do. Well, goodbye from the hobby room.
Water bears live from the deepest ocean trenches to the tops of mountains, from tropical rainforests to the Antarctic. They're short and plump, with 4 pairs of legs. They move slowly in a lumbering gait like a bear, which is why they're called water bears. Their scientific name is tardigrade, which means slow walker. Adult water bears are typically 500 microns to 1 millimeter long. Their favorite food is moss, and they're most commonly found in streams, rivers, or ponds. What's amazing about water bears is their resilience. They can survive pressures up to 600 megapascals, 6 times that of the deepest ocean trenches. They can also survive radiation hundreds of times the dosage that would kill a human, without food or water, at temperatures down to minus 458 degrees Fahrenheit, or beyond boiling. Perhaps most amazingly, they can survive the vacuum of space. How do they do this? By going into a hibernation state, they replace the water in their cells with a glassy resin, which preserves them and their DNA even from space radiation. In this state, their metabolism is suspended, and they can go without food or water for more than 30 years. Understanding how these remarkable creatures function can help us understand human factors and habitability for space exploration. Did you know that there may already be water bears in space? On April 11, 2018, the Israeli satellite Bereshit planned to land on the moon. It carried with it a backup of planet Earth, including thousands of tardigrades. The satellite crash-landed, spilling tardigrades all over the lunar surface. I wonder if they survived. Here at Aerospace, we're doing our own experiments to explore how these amazing creatures survive in vacuum. How are we doing this? Well, we can create a space-like vacuum in one of our small chambers by removing all the air after we've added some water bears inside. We expect to see the water bears in vacuum go into their dormant cocoon-like state. This is called a ton, and they can remain in this state as long as they are exposed to vacuum. When the air is returned to the chamber, we expect them to return to their original bear-like form. At Aerospace, we have several samples of water bears, and they are living happily in the Propulsion Science Laboratories under the care of Dr. Andrea Hsu. We'll be keeping you posted with their latest news.